Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
The quiet genius who predicted antimatter, how Paul Dirac revolutionized modern physics. Imagine a quiet, introverted math genius who predicted the existence of antimatter. This isn't just a pinnacle of physics, it feels almost like a superpower, a prophetic vision of the quantum world. Paul Dirac showed us a whole new side of reality. Now, you might be wondering, who was Paul Dirac really? He was a man of few words, almost never spoke to anyone. Yet, somehow, he stood at the summit of quantum physics, founding some of the most groundbreaking areas of modern science. If you've ever asked yourself how such a quiet person could have achieved so much, you're not alone. Dirac's life is nothing short of a miracle. How did a math prodigy with a calm demeanor ignite scientific revolutions that changed our view of the universe? He didn't just write a mathematical equation, he made particles, even antimatter, visible. He predicted antimatter's existence with a formula, and decades later, his prediction was proven true. If that isn't superpower level stuff, what is? But, believe it or not, Dirac's story didn't start with a groundbreaking experiment or a wild prediction. In fact, it all began like many quiet geniuses do, without much fanfare. No grand announcements, no loud applause. He wasn't the social butterfly you'd expect from a scientific prodigy, and yet, somehow, he managed to quietly revolutionize the field. So, why did this seemingly ordinary, introverted math geek become a world-changing physicist? That's the mystery we're about to unravel. Let's take a closer look at how this reserved genius slowly but surely climbed to the very top of the physics world. Dirac's parents probably never imagined their quiet son would one day challenge the laws of the universe. He wasn't one to talk much, didn't make friends easily, until math became his only friend. Born in 1902 in Bristol, England, Paul Dirac's parents weren't exactly scientists. His father was an engineer, and his mother was a piano teacher. It wasn't your typical science household, but their strong focus on education played a big role in shaping his future. Dirac had a natural affinity for math from a young age, enjoying solitude and quiet thinking. Even at school, he was a complete bookworm, hardly interacting with other students. He was the quintessential nerd. Unlike many of the social butterflies we associate with groundbreaking scientists, Dirac's quietness and introversion made him stand out in a different way. He didn't chat much, didn't give lectures or public speeches. His world was made up of cold, abstract numbers and formulas. And while his parents might not have understood his reclusive nature at first, it's this very isolation that helped him nurture his immense mathematical talent. At Bristol University, he wasn't exactly given the chance for much socializing, but it was here that he first glimpsed the door to physics. His interest in the subject began to grow, and little did anyone know, this quiet student was on the brink of changing the way we understand the universe. Imagine that, at such a small university in a quiet town, a future physics giant was an almost invisible student with barely any friends. But this solitude didn't hinder him. On the contrary, he poured all his energy into the subjects he loved, math and physics. His talents quickly became evident, and his skills began to speak for themselves. In fact, his academic journey didn't really have any major aha moments or public applause. He quietly immersed himself in his studies, steadily becoming a star in his own right. From that shy, solitary teenager to the towering figure in physics he would later become, Dirac's journey could almost be seen as a plot twist in a movie, quietly breaking through the barriers of physics, revolutionizing our understanding of the quantum world. His early years didn't just set the foundation for his groundbreaking discoveries, they also taught the scientific community an important lesson: you don't need to shout from the rooftops to change the world. All you need is a passion for what you love, and that passion will carry you to the world stage. When Dirac arrived at Cambridge University, he wasn't immediately the star scientist you might expect. If you've ever imagined that great scientists must be instantly recognized, you'd be wrong about Dirac. He didn't walk into Cambridge and immediately captivate everyone's attention. Instead, he was that quiet, reserved student, hardly the kind of person you'd expect to change the world. But it was precisely this outsider status that allowed Dirac to take quantum mechanics to new heights, almost silently changing the entire field of physics. In 1923, Dirac joined Cambridge's prestigious Cavendish Laboratory, known as the Mecca of scientific research, a place full of top-tier scientists. But Dirac didn't get overwhelmed. On the contrary, he thrived in this academic jungle. While others scrambled to fit into the system, Dirac simply used his own approach to tackle quantum mechanics' toughest problems, gradually becoming a hidden gem in the scientific community. You might think Cambridge was a place of intense competition, but for Dirac, it was his perfect environment. He didn't need to follow the rules of socializing or ingratiating himself with the established scholars. He just went on solving problems in his own way. And before long, his extraordinary talents started catching the eyes of his mentors and peers. Interestingly enough, Dirac's first academic paper was published with little fanfare. There were no press releases or headlines, but that quiet paper would go on to shape the future of physics. Dirac's research didn't depend on being in the spotlight. His breakthrough came from focusing on solving problems rather than gaining attention. His brilliance lay in his ability to remain independent of conventional theories, instead using meticulous mathematical deductions to carve out a completely new path. This independence quickly made him stand out. His calculation skills and logical reasoning went far beyond what anyone else in the academic world was doing. In fact, Dirac wasn't just finding his place at Cambridge, he was setting the stage for his own scientific revolution. His professors and peers soon realized that this quiet student had an extraordinary mind. Unlike others, Dirac didn't rely on mimicking existing successful theories. His thinking was about breaking through boundaries, and those breakthroughs laid the groundwork for pushing quantum mechanics to unprecedented heights. Now, let's talk about the two big giants in physics, quantum mechanics and relativity. These two theories were the reigning titans of the science world, opposing forces that never seemed to get along. It's like picturing two superheroes, one controlling the micro-world and the other governing the macro-universe. The two just didn't mix. Until Dirac came along and, with a single equation, bridged the gap between them. It was like magic in the world of physics. In 1928, Dirac introduced the famous Dirac equation. This equation wasn't just another theoretical exercise, it was a game changer. By combining quantum mechanics with Einstein's theory of relativity, Dirac resolved a conflict that had plagued physics for years. Quantum mechanics dealt with the uncertain behavior of tiny particles, while relativity described the large-scale movement of celestial bodies. These ideas seemed to be at odds, but Dirac's equation brought them together in harmony. Imagine trying to combine fire and water. That's what Dirac did, but somehow, he made them work together. Imagine this, a quiet, introspective genius in mathematics, who somehow managed to predict the existence of antimatter. This wasn't just a high point of physics, this was something straight out of a science fiction story. Paul Dirac showed us a whole new side of the universe. You might be thinking, isn't this equation super complicated? Well, you're right, it is complex. Especially the math behind it, which can make your head spin. But for Dirac, this wasn't a problem. His approach was so simple, so elegant, that later, many physicists would call it mathematical art. But the true magic of Dirac's equation wasn't just in its elegance. It did something that no one had done before. It solved a problem no one had cracked: the behavior of electrons in the quantum world, while simultaneously aligning with the theory of relativity. And that's not all, it predicted something truly groundbreaking: spin. Spin is like an internal property of particles, a special trait that electrons and other particles possess. It was a game changer, revolutionizing how we understood how particles interact and move, especially in magnetic fields. But wait, there's more. Dirac's equation didn't just lay out how particles like electrons behaved. It foretold the existence of antimatter. Yes, you heard that right. Dirac predicted the existence of positrons, particles that carry the opposite charge of an electron. At the time, almost no one believed him, thinking it was pure fantasy. But in 1932, the discovery of the positron proved Dirac's prediction was true, cementing his place as one of the most visionary scientists in history. So, you're probably wondering, how on earth could an equation predict something like antimatter? It's like a mathematical crystal ball. Dirac's equation was much more than just another formula, it was a window into a whole new reality. But the real kicker? It wasn't just theory. In 1932, physicist Carl Anderson made the world-changing discovery of the positron in an experiment. Suddenly, Dirac's fictional particle was staring us in the face, validating his incredible foresight. Think about it, in the 1930s, Dirac was essentially seeing particles that hadn't even been discovered yet. It's almost like he was a prophet of physics. With just his equations, Dirac predicted the existence of a particle that would change the course of scientific history. This discovery didn't just shift our understanding of particle physics, it opened up an entire new field. Antimatter went from being a crazy sci-fi idea to a real, scientific mystery. And you might wonder, what's the real-world importance of antimatter? Well, if you've ever seen Guardians of the Galaxy or Star Trek, you know that antimatter could fuel spaceships or power destructive weapons. Okay, we're not quite there yet, but the implications for modern physics are massive. From that point forward, particle physics wasn't just about regular particles, it was about exploring this mysterious opposite, antimatter. Dirac's equation revealed to us that the universe is much more complex than what meets the eye. And while we're talking about Dirac's mind-blowing contributions, it's worth mentioning that Dirac wasn't just a math wizard, he was a philosopher at heart. He didn't just get lost in his numbers, his deep philosophical view of science shaped his work. You might think of Dirac as this boring scientist, someone who was always buried in equations and never took part in the typical academic banter. But in truth, his view of physics was anything but ordinary. He believed that the beauty of physics lay in its simplicity and symmetry, just like the elegant formulas in mathematics. For Dirac, the ultimate goal of physics was to find the simplest, most elegant expression for the universe's deepest truths. But here's where it gets even more interesting. Dirac was so focused on his theories that he didn't really care about socializing or attending conferences. In fact, many of those who knew him described him as cool to the point of being unreachable. He was a man of few words, and his calm, almost mysterious demeanor made him seem like a puzzle. But what a brilliant puzzle he was! Dirac's quiet nature wasn't from lack of confidence, it was a sign of his deep dedication to science. He didn't chase fame or accolades. He believed that scientists should be true to their theories and discoveries, not seeking the spotlight. He was like a philosopher in the science world, quietly reshaping the foundation of physics. And even though Dirac wasn't one for big speeches or public debates, his influence on other scientists was profound. His philosophical views and dedication to science inspired countless physicists and mathematicians, especially when it came to understanding the nature of science itself. Sometimes, Dirac's lifestyle might make him seem eccentric, but in reality, it was this very eccentricity that made him great. After all, the true scientist doesn't care what others think, they care about what they can discover. And Dirac was that kind of scholar, committed to his scientific philosophy, regardless of the outside noise. Now, let's talk about one of the direct outcomes of Dirac's groundbreaking work, the birth of quantum electrodynamics, QED. You might be wondering, what is quantum electrodynamics? Well, buckle up, because it's like a magic formula that explains how light and electrons interact, not in some mystical sense, but in a way that can be described by mathematical equations. QED isn't just some magic trick, it's one of the coolest theories in quantum physics. Imagine electrons and photons, basic particles that don't just bounce off each other in space. They interact, like a couple in a dance, pulling each other in, reacting to each other's presence. Sounds like a love story, right? Well, QED is the magical theory that describes this interaction. It's the combination of quantum mechanics and electromagnetism, a supertheory that explains how photons, particles of light, and electrons exchange energy. And those virtual photons I mentioned? They're not some invisible drink you can sip and forget, they're real mathematical tools that help us understand how particles in the microscopic world interact. And that's not all. Dirac's work laid the groundwork for later particle accelerators like the Large Hadron Collider, LHC, which use QED to unlock the deepest secrets of the universe. Without Dirac's magic equations, these high-energy collisions wouldn't have been possible. But the influence of QED doesn't stop there. It also paved the way for advances in nuclear energy and quantum computing. The precise understanding of particle behavior that QED enabled is crucial in fields like nuclear power, where mastering how particles behave is key. And when it comes to quantum computing, well, QED's influence is at the heart of how quantum bits, qubits, interact through quantum entanglement to perform high-efficiency calculations. In short, Dirac's equations didn't just break barriers in theoretical physics, they opened the door to an entirely new realm of possibilities in science and technology. These magical formulas were the key to unlocking modern physics, and without them, our world would look very different today. So, the next time you marvel at the rapid advancement of modern technology, remember this: behind it all, there was a quiet, humble mathematical genius. Paul Dirac didn't just change the face of science with his equations, he made particles start their own love story and propelled advancements in nuclear energy, quantum computing, and particle physics. Yes, science can be romantic, can't it? They say winning the Nobel Prize is easy, it's keeping a low profile afterward that's the real challenge. And Dirac, he nailed it. Winning the Nobel Prize in physics wasn't just a nod to his groundbreaking equations, but also to his global impact on quantum mechanics and modern physics. If you're a physics fan, you might wonder, why exactly did Dirac win the Nobel? Don't worry, we're about to uncover that. In 1933, Dirac was awarded the Nobel Prize for his pioneering work in quantum mechanics. It wasn't just about his famous Dirac equation, it was about the revolutionary way he integrated quantum theory with Einstein's relativity. Back then, physicists were stuck, grappling with the conflicts between relativity and quantum mechanics. Dirac's work shone like a beacon in the dark, offering a way forward that would change physics forever. But here's the kicker: Dirac's reaction to winning the Nobel was completely different from the usual. Most Nobel laureates are all about the spotlight, giving passionate speeches, becoming public figures. Not Dirac. He kept his low-key lifestyle. In fact, he didn't seem to care much about the honor at all. He was the epitome of calm, almost like he'd rather be left alone to think in his lab than stand on stage. It makes you wonder, right? How could someone achieve so much and keep it all so deeply under the radar? Dirac didn't show off his academic contributions. Instead, he let his astonishing theoretical work do the talking. His influence crossed borders, transcended disciplines, and made him a giant in global physics. In the world of physics, Dirac's name is nothing short of legendary. Not only was he the creator of the Dirac equation, but he also laid the foundations for quantum electrodynamics, QED, and quantum field theory. His impact is far-reaching, from particle physics to modern technologies. Just look at particle accelerators, quantum computing, or nuclear energy, all of which rely on his complex formulas. But how did this quiet genius manage to hide his monumental achievements? The Nobel Prize behind him only emphasizes that true greatness doesn't need a loud voice, it speaks through real contributions that push the world forward. Dirac's global influence wasn't just about his equations. It's about how his work reshaped the entire scientific community and changed the course of technological progress. His low-key lifestyle taught us an important lesson: greatness doesn't require a spotlight, it will shine on its own in the annals of history. Today, when we talk about quantum mechanics, particle physics, and antimatter, Dirac's name is inseparable from those concepts. We often hear phrases like the prophet of the quantum realm or the father of particle physics. But behind those labels is a quiet, reserved mathematical genius whose legacy is woven into every corner of modern science. Dirac's scientific legacy is like an epic in physics. The quantum mechanics we study wouldn't be the same without his equations. The particle physics we explain, his theories on electron behavior, antimatter, and photon interactions laid the groundwork. And when we honor quantum computing, we're honoring Dirac too. Think about it: Dirac didn't just give us equations, he opened the door to the microscopic world, giving us the key to explore the universe's deepest structure. Quantum computing? You can't talk about it without Dirac. The reason quantum computing is one of today's hottest fields is that quantum electrodynamics, QED, and quantum field theory provide the foundational framework for handling quantum information. Dirac can be seen as the father of the quantum world, and his theories paved the way for the quantum computers and communication systems we're developing today. More than that, Dirac helped push forward global scientific collaboration, helping us better understand particle accelerators and high-energy physics. Without his theories, we might still be struggling to comprehend how particle colliders like the Large Hadron Collider, LHC, help us explore the microscopic world. And it's not just the academic world where Dirac's impact is felt. His contributions shifted the entire global perspective on basic science. He didn't just transform physics, he inspired countless young scientists and engineers to pursue the seemingly impossible. Just think about it, antimatter, once a figment of sci-fi imagination, is now a real concept in the physics world. All of this started with Dirac's equation, and its ripple effects are still being felt today. Sometimes, Dirac's achievements might feel like they're out of reach, but through his science, he gave society a powerful message. Science isn't just about formulas, it's about the power to change the world. Today, quantum mechanics is solving problems in fields like computing, communication, and medicine. All of it can be traced back to Dirac's legacy. You could say Dirac was more than just a giant in physics. He was also a driving force for societal progress. Imagine if Dirac were a superhero. Sure, he saved quantum mechanics, but he also made antimatter the star of physics. Antimatter was once a fantasy, a myth, but Dirac made it real with just an equation. And now, scientists are exploring how to harness antimatter for energy solutions. Who knows? Maybe antimatter will help us solve the energy crisis of tomorrow. When you look back on your life from the pinnacle of science, would Dirac ever have imagined that he, just a math-driven physicist, would lead the way to such world-altering discoveries? As he saw his theories propelling scientific progress across the globe, would he have thought, "I just wanted to write an equation to understand the secrets of the universe"? But in doing so, he shattered our understanding of the world and expanded the boundaries of nature itself. Dirac's story brings countless lessons. His contributions weren't just theoretical, they took science from abstract math to practical, real-world application. From the moment he introduced his equation, the world began to see a clearer scientific reality. His influence continues to ripple through every aspect of our lives, from fundamental physics breakthroughs to cutting-edge quantum computing technologies. His name is etched in every page of scientific history. And perhaps Dirac never realized his life wasn't just about solving physics puzzles, it was about leaving humanity a rare intellectual inheritance. He didn't chase fame. He quietly did his work, and that devotion to science made him a hero in the eyes of scientists everywhere. Today, as we explore the frontiers of quantum mechanics, we're standing on Dirac's shoulders. If you're working at the forefront of quantum mechanics today, how would you apply Dirac's ideas? Is there another Dirac out there, waiting to use an equation to foresee the future and change the world? Dirac's story isn't just a victory for science, it's a victory for humanity and responsibility. His achievements remind us that scientists don't just push knowledge forward, they also carry the responsibility of shaping society's future. As we stand on the cutting edge of science today, we continue to draw wisdom from Dirac's story.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.